Pyq'S.com.
Okay, students, now we are going to start chemical bonding. Chemical bonding, previous year questions. It is a mixture, these questions are mixture of the NEET questions, mains question and advanced question. Okay. And it is randomly arranged. Some questions are in the starting, some questions are in the ending, so that people should not follow any book. Okay. And the different pattern you should understand. So I will give a time, you can pause the video and you can answer, then you can go for the your own you can go for the my explanation. Okay. So let's start one by one. And here is the first question. Okay. Each and every page almost contain two questions. Okay. So let's start with the first question. The species having bond order different from that in carbon monoxide. Okay. So like this is a JE 2007 paper 1. Okay. That is advanced question. Like that some are mains question, some are NEET question. Okay. So you can try your answer, then cross check with my explanation. Okay, after checking your answers, now I am able to understand most of you are time consuming. Okay, so for avoiding time consuming and without losing accuracy, I will tell you the shortcuts. Okay, so that is the difference between going through the books and attending the video lecture. Okay, so there is a sentence in my one shot lecture. In my one shot lecture, I have explained bond order is same for all isoelectronic species. Okay, there is a sentence in the one shot lecture. So if you attend that one shot, almost 4.5 hours, so you can attend that lecture by taking break. Okay, you can take five times you can attend, because I don't want any important point to be missed. That's why that is lengthy. So if you feel that, you can take 45 minutes and five times you can attend. Okay, but each and every point is exam oriented and clearly explained without thinking that it is a one shot. Okay. So in that sentence is that uh, bond order is same for isoelectronic. So here if you find number of electrons are 14. Okay. So need not to find bond order. Though many students are able to answer, but they are taking more time. So taking more time is also very dangerous. So just you count the total number of electron. In the first option, you will find NO minus. Okay. NO minus means it will be 7 plus 8 plus 1. This is 16 electrons. So it is not isoelectronic, therefore it cannot have the same bond order. Okay. So answer A itself is correct. Understood? So like that you can save your time and proceed till the last. Okay. With same enthusiasm, same interest, and get the shortcuts. Now next let us see the least stable resonance structure among the following. Okay. So resonance structure, what are the resonance conditions of resonance also I have explained, and stability on what factor they depend, that also explained in the one shot. Okay. So let's see, within short span of time with maximum accuracy we will be able to do it or not. So this is the question where maximum people answered wrong, and that means some problem with the understanding the stability. So least stable here, this question is based upon the location of the charges. Okay. So if charges are there, they should not be very nearby. They should not be very nearby. So here see, positive are very nearby, negative are very nearby. So because of that, repulsion will be more. Once repulsion is more, then what happens? Stability will be less. Okay. So the answer to this question is A option. A option, try to write the reason. Similar charges are at the close proximity. Similar charges are at the close proximity, therefore it is least stable. Note down with the reason. Okay. Now let's start with the next question. Okay, see, this is a memory based, but it is not accurate, it is not exact value you should remember. At least you should have, see here, kilocalorie. People generally give values in the kilojoules, but the question is about the kilocalorie and it will be approximately 100. Okay, so that means in the 2010 advanced exam, they used to give some memory based approximate values also. Okay, so this is the C option is correct. Now let's see the next question. The pyramidal shape. The pyramidal shape is, okay. Answer is OSF2. What is the answer? OSF2. So here the main problem when I discussed with the student, they came out that they are not able to identify which is the central element and how to write the rough structure. Okay. Simple here, maximum valency is of the sulfur. So you will write sulfur. Okay, and oxygen valency is 2, so you will write oxygen, and fluorine. Okay, so apart from that, sulfur have total 6 electron, only 4 electrons are involved, so this will be the lone pair. Okay, now if you find here as a shortcut, I have explained in the again one short lecture, I have explained without formula. People are studying formula, that formula also I told you in one shot. Without formula, without substitution, without simplification, you can find out like this. Okay, so it is 3 sigma bonds plus one lone pair also can be considered as a sigma bond only. So total it will be 4. So 4 means sp3 hybridization. sp3 hybridization with one lone pair will be pyramidal shape. Okay. So this is all about the OSF2. Understood? Actually, it should be SO4 negative, then it will be tetrahedral. BRF3, like that if you find out. Okay. Like that if you find out. Okay, so here if it is BRF3, if it is BRF3, there will be 3 sigma bonds. Okay, there will be 3 sigma bonds out of 7 electron. 4 electrons are left over, therefore 2 lone pairs. Okay, 3 plus 2 it will be 5. And if it is 5, then what is the value here? sp3d. Okay, in sp3d you can never have the pyramidal shape. Okay, that's why answer will be OSF2. Like that you can solve for the SiO3 2 negative also. Okay, so this is about this question. Now let's solve the next question. Okay, next question. One of the following molecule is expected diamagnetic behavior. Diamagnetic behavior. Okay, try to solve and tell me the answer. Okay, this question was very tricky word. It is question is expected to be. Because of these words only I clearly mentioned. Okay, that molecule, who is that molecule? Oxygen. Because of oxygen molecule, in one shot I have explained why MOT is required. MOT is required just to explain the unexpected behavior of the oxygen. Okay, so if the question is which one of the following is diamagnetic, then you can compare with others. Understood? So this is expected and diamagnetic is not a problem. Okay, so if this expected word is not there, then C will not be answer. Okay, so let's start with the next question. Which one of the following is wrong statement? Okay, which one of the following is the wrong statement? Is it understood? So try and see, so many things are covered here. Isoelectronic, bent, shape, color, magnetic nature, all you should be worried about. Okay. Okay, here very simple, not isoelectronic. Okay. If you add all of them, here it will be 6 plus 7 plus 6 plus 9. Okay. And here if you count, tell me how many answers you will get. Okay. Just wait. I think some problem is there. Actually, sir, some spelling here mistake is there. This is not there. Okay. So in that exam, in the 2013, it was ONF. Okay. So that time this was the option. Here they are isoelectronic. Okay. But it is given not. That's why A option is correct. Okay. Spelling mistake here it is C. C is not there in the exam. Okay. Now let's go to the next question. So anyhow, if the answer to this question is A and answer to this question is C. Now let's see the next questions. Okay, next question is which one of the following pair of molecule oblique ions, both species are not likely to exist. Not likely to exist means you should take the bond order. Okay, you should take the bond order, then you will identify. Okay. Okay, this question is based upon the bond order. If bond order is 0, that means it does not exist. Okay, so see here in the C option, there are no electrons. So once no electron does not exist, here bond order will be 0. So both, here question is both should not exist. Okay, so answer is C. Okay. So H2 2 plus is 0 because no electrons are there. He2 you will get 0 bond order. Now let's see the next question. Stability of the species Li2 minus, Li2 plus increases in the order of. Okay. Now try. Okay, here you have to find out the bond order. What you have to find out? Bond order. And people are getting doubt just because of this. Okay, here I am writing the bond order. Bond order of Li2. Okay, Li2 plus and Li2 minus. Both are same. Here problem is with this Li2 plus and Li2 minus, both bond order are same. So people don't know when bond order is same. Then in our one shot lecture also in the last it is explained when bond order is same, then you have to solve with the respect to anti-bonding molecular orbital electrons. Okay. So here in the Li2 minus, number of anti-bonding electrons are more, therefore it is less stable. So answer will be B option. Okay. So this principle for comparison must be used only when bond order is same. Once bond order is same, then you will compare with the number of anti-bonding electron. Whichever species is having more anti-bonding electron will have less stability. Okay. So B option. What is the answer? Answer to this question is B option. Okay. Now let's see the next question. Okay, this is an advanced question and more than one correct answer. So everything about hydrogen bonding you should know, then only it will be easy to answer. Okay. So let's see more than one correct answer. Okay, see here it should be the application there. The reason should have something related to the hydrogen bonding. Okay, suppose I have explained ice floats over water. Okay, what is the reason? Due to intermolecular hydrogen bonding. What is the reason? Due to intermolecular hydrogen bonding. Okay, and there is a integer type question also I have explained in the lecture. So because of intermolecular hydrogen bonding, it possesses cage like structure. It possesses which like structure? Cage like structure. Okay. So therefore that is correct. It is related to hydrogen bond. Higher Lewis basicity of primary amine. In the aqueous state, actually, amines order is discussed in two types. In gaseous state, some other order, and aqueous state, some other order. Okay. So primary amine stability will be depending on the protonation by the water. So protonation by the water will further depends on the number of hydrogen bonds. Okay. Protonated amine, how many hydrogen bonds it is able to form. Based on that, Lewis basicity is expressed in case of the aqueous. In gaseous state, hydrogen bond got no role. So here it is discussed about the aqueous solution, therefore it is correct. Okay. Then formic acid is more acidic than acetic acid. It got inductive effect. So no role with respect to hydrogen bond. And dimerization of acetic acid, it is intermolecular hydrogen bond. So it is also hydrogen bond related. D is related, B is related, and A is related. So answer to this question will be A, comma B and D. Okay. Now let's see the next question. Assuming 2s 2p mixing is not operative, the paramagnetic species of the following is. Okay. 2014, the most contradictory question is this one. Okay. Let's see who will answer this question. Okay, this is a complete electronic configuration I have written by considering no 2s and 2p mixing. Okay, this is electronic configuration where you have to consider no 2s 2p mixing. See here, there are two unpaired electrons are there. Okay, so because of the two unpaired here, no unpaired electron, no unpaired electron. Therefore, C option is correct. Okay, that is no, not considering the 2s 2p mixing. Is it clear? Very important question, most contradictory question of the 2014. Okay, next question is the intermolecular interaction between, that is dependent on inverse cube of the distance between. This is very beginning and people are not studying. To the power of 6, to the power of 3, to the power of minus 6, their values are given. So very simple, but instead of, because of neglecting, this is not attended by the most of the student in the 2015. Okay, to the power of minus 3, it should be to the power of minus 3. In some way places it will be to the power of minus 6. Okay, so you have to make it in the to the power of minus 3 where it is to the power of minus 6 where it is. Okay. Okay, so this is just memory based. You can mark how many of them are inversely proportional to the 10 to the power of 6 and how many of them are inversely proportional to 10 to the power of 3 cube here. So answer is ion dipole interaction. Okay. Now let's see the next one. Which one of the following statement about water is false? You have to identify the false statement. You have to identify the false statement. Okay. So this is question is all about the careful study. Okay. Here if you carefully study, it is written intramolecular. Actually it should be intermolecular. Okay. So intermolecular is should be written, but it is written as intramolecular. That's why it is false. So C option is correct. Okay. Now let's see the next question. Okay, next question. According to molecular orbital theory, it is also advanced question. So more than one correct. Up to here there is a question. D option only first question. Next question is another question. Okay. So try to analyze all questions. It may be more than one correct. It may be single correct also. Okay, here in this question, molecular orbital theory, if you write the electronic configuration below 14 and above 14, why it is? There is a change in configuration and where it will result into the paramagnetic, where it will result into the diamagnetic, it is explained already. Okay, so here answer to this question is AC. What is the answer? A comma C. Now try the next question. Try the next question. Okay, as it is a simple mains question, it is single correct option. Okay, and main problem is not paramagnetic. You have to answer not paramagnetic as a short trick. Okay, as a short trick, I tell you, as a short trick. Okay, it is a odd electron molecule. Whenever this is odd electron molecule, it have to be paramagnetic. Okay, so because of that, NO is paramagnetic, but it is written not paramagnetic. Okay, okay, next question. Which one of the following compounds contain no covalent bonds? Actually it is spelling mistake. Bonds, covalent bond. Okay, so start answering very carefully. Okay, here this everywhere you have to check, like B2H6. There is no problem with the KCl, but problem is B2H6. B2H6 also contain three center two electron bonds. Okay, so answer to this question is KCl. What is the answer? KCl. Okay, then total number of lone pair electrons. Total number of lone pair electrons. Okay, here total number of lone pair. So answer is D, 9. Okay. So how it is 9? Because of the I3 minus. Okay. I3 minus, it is not about the central atom. Okay. So this will contain 3 lone pair, this will contain 3 lone pair, and this will contain 3 lone pair. So when you add all of them, you will get 9 lone pairs. Okay. So I think it is clear now. Let's go to the next question. Okay, next question is, according to multi-orbital theory, which one of the following is true with respect to two, Li2 plus and Li2 minus? Okay, in the previous PYQ only I told you they both are stable, but it is not that equally stable. Understood? Whenever fractional bond orders are there, there may be resonance. What may be there? There may be resonance, so both are stable. What is the correct answer? Both are stable. Okay? Answer to this question. Now you can try the next very beautiful question. Okay, answer to this question is, if the question is less stable, more stable, then you can compare the stability like this. Okay, now let's see the next question. In which of the following process the bond order has increased and paramagnetic changed to diamagnetic? So everywhere you have to compare both. Okay, okay, these are the variation N2 to N2 plus. The magnetic behavior is changing from dia to para, and bond order is changing from 3 to 2.5. Okay, same way NO to NO plus, para to dia, and bond order is changing from 2.5 to 3, and oxygen O2 to O2 minus, para to dia, and magnetic behavior is changing from 2 to 1. O2 to O2 plus, para to para, then it is 2 to 2.5. So these are the details. Now let us cross check according to this which is correct. Okay. So in our question, which matches? I think it is CO2 to 2 minus. They want that bond order has increased. Okay. Bond order has increased and paramagnetic changed to diamagnetic. Okay, bond order has increased. According to that, which is correct option? Bond order should increase and paramagnetic to diamagnetic. You can compare and answer. So here both properties, both properties are matching in the B option. So for this answer is B option is correct. Okay. Here NO to NO plus, it is changing from the para 2. Okay. First we have to check the bond order. Bond order is increased from 2.5 to 3. Okay. And paramagnetic nature changed to diamagnetic. It is para, odd electron, and it is dia N2. It is as good as N2 only. Okay. So B option is correct. Those who answered B option, they are all correct. Okay, next question. The pair that contains two pH bonds in each of the oxo acids. pH bonds you have to find. Do it very carefully without doing any mistakes you should do. Okay. Okay, here very simple. If you are perfect about the how to draw the structures, you can identify here itself A answer. Okay. H3PO2 will contain two pH bonds. Okay, one P double bond O and OH. Remaining two hydrogens will be in the single bond. Okay, so H3PO2 will have two single bonds, and like that, if you draw, you can find two single bonds in this structure also. How to draw the structures of oxo acids? In 15th group also we have discussed, and 16th group also we have discussed. Okay. Then greater ability to form P pi multiple bond. Simple answer, D answer. Okay. What is the answer? D is the correct option. Okay. Next question. It is a match the following but made it as a options. Okay. You cross check with the options given here. Then you can answer. So many things are connected. Magnetic, S&P mixing, bond order, reduction, oxidation. So everything you cross check. You can take time because this is a time taking question, but don't give expected answers. You will get negative marks. Okay, these type of question you have to answer in a tricky way, otherwise it is time consuming. So first of all, suppose if you are perfect in first option itself, B2 if you cross check, okay, and you cross check with suppose 1, okay, B2 is paramagnetic, then therefore you need not to worry about the B and C option, you need not to worry about that, okay. Then you need not to worry now about the second option. You can directly check with the third option. Okay. Suppose if it is third option. Okay. If it is third option, that means number of electrons are more. Okay. Bond order increases. Then it will undergo reduction. Okay. What is this undergoes reduction and oxidation? I am telling you, listen carefully. Suppose B2 have less bond order, B2 have less bond order, and B2 minus have increasing the bond order. Okay. So that means it will accept the electron and become stable. So that time it will undergo reduction. If it is B2 have less bond order, more bond order, and B2 minus have less bond order, and B2 plus have increasing the bond order, that time it will lose electron and undergoes oxidation. That way you have to compare. So if you compare like that, it will undergo reduction. Okay. B2 will undergo what? Reduction. So third answer is correct. Then mixing of S and P orbital will takes place. Okay. Mixing of S and P orbital will takes place. So answer is 1, 3 and 5. Okay. A option is bought. 1, 3, 5 is the correct answer. So this answer is D option. Need not to worry about further. Okay. But you should be very confirm about A option. There should not be any problem in the A option. If you have problem in A option, then you can try with the B. Wherever you are confirmed, then only you should lock to that answer. Okay, this is about the type of pi bonds. Understood? In the molecular orbital theory, we have a lecture in the digital board how to find out the pi bond and how to find out the sigma bond. In that again anti-bonding and bonding. Okay? Identify and match the following. So these are the structures given and here the options are there. and options accordingly you can select A, B, C, D. Okay. Okay, so I am just connecting it here. Here both are d orbital and head-on overlap. Okay, it should be dd sigma bonding. So A answer should be 2. Okay. Now then we will change the options. Some problem in the options, I think. Okay, this is p orbital, this is d orbital. Sideways overlapping is taking place. So PD pi bonding. Okay. PD pi bonding. Understood? So PD pi bonding. Then next, this is also PD. Now you can see here. Actually, here I think color problem also. C and D both are same. Okay. So B can be, let us take as a 3. C can be 1. Okay. There is some print mistake here. And here it is D. This is DZ square. D and D. Okay. And the color it is plus and minus. So if this plus and minus anti-bonding. So this will be the, so let us check with that. C should be, B should be 3, C should be 1. Okay, which option? Otherwise leave it. Okay, so answer to this question is A will be 2. Okay, B will be 3 or 1. No problem, because both are structures are similar. Okay, B can be 3 and C can be 1. Okay, and D will be 4. D will be 4. So D4 we have these two. Okay, C2 is also okay. Now it is clear. So you write this option accordingly. There may be some printing mistake here. Okay. See, pi and sigma bonding, it is clear now. Then pi bonding and anti-bonding. Suppose normally they will give like this, plus with plus. Okay. Then it will be bonding. Understood? Constructive interference. If it is plus with minus, okay, then it will be anti-bonding. Actually, here see, it is dark and it is light. So this will be anti-bonding and head-on overlap of the d orbital. So sigma bond. Sigma bond and anti-bonding. Like that you have to identify. Okay. So the let us take this as a negative. Blank means negative and filled means positive. So positive with negative, that means anti-bonding. Okay. Positive with positive bonding, negative with negative bonding. That is the way you have to identify anti-bonding and bonding. Okay. It is clear now. Okay, next is integer type question based on Vesper theory. Number of 90° in BR F5. Number of 90° in BR F5. Okay, very good question. Let us see who will answer this correctly. Okay, here in the, if you find out the hybridization and structure, it will be sp3d2. What will be the hybridization? sp3d2 and one lone pair. So it will be square pyramidal. What will be the structure? Square pyramidal. Okay. One fluorine will be here, another fluorine, second fluorine, third fluorine, fourth fluorine, and fifth fluorine. So actually it is supposed to be number of 90°. 1, 2, 3, 4 and 4 here. 8 should be the answer. But because of this lone pair, this repulsion will be more. So all will lose their perpendicularity. Okay. So answer to this question is 0. Understood? Number of bond angles must be how much? 90 should be 80. 8 90° should be there. But because of lone pair repulsion, lone pair bond pair repulsion, it will not be exactly flat. It should bend like this. It should bend like this. So because of that, all 90° angles will be lost. Okay. Answer is 0. Now try the next question. Okay, here answer question what it says that it should have linear shape. First of all, uh, should not have contribution from d orbital. Okay, and what it should have? Triatomic molecule, linear molecule. So bond angle must be 180, but it should not have the d orbital. Okay, that means what is left over? Only sp hybridization. It should have sp hybridization. Then you will get answer of 4. Sometimes sp3d with 3 lone pair also will be linear shape. Okay. So, but don't consider that because it is said d orbital should not be available. Is it clear to all of you? So, answer is only 4. What is the answer? Answer is only 4. Okay, next questions. Again, advanced question and integer type question. The sum of the number of lone pair of electrons in each central atom. Central atom only will consider. Okay. So let us see who will be the fastest and accurate. Okay, here is the answer. First we'll have one lone pair, next to two lone pair, zero lone pair, and three lone pair. Total number of lone pairs are 6. Total number of lone pairs are what? 6. Okay. Next, among H2, He2 plus Li2, Be2, C2, N2, O2 minus F2. Diamagnetic species. You have to count diamagnetic species. Okay. Try and answer. Okay. Here answer again 6 only. What is the answer? 6. We have to identify diamagnetic. Okay. First of all, H2 is diamagnetic. Okay. Li2 is diamagnetic and Be2 is also diamagnetic. Okay. C2 is also diamagnetic and next N2 is also diamagnetic. Total how many? 5 are there. Okay. O2 paramagnetic and F2 is also diamagnetic. So answer will be 6. 3 plus 3 6. Okay. Is that clear? Now let's see the further. Okay, next question. XeF4 plus O2F2 product. Total number of lone pair on the xenon containing the product. Product you should write, then you should count the answer. Okay. So that means reactions also you should remember and product chemical bonding also you should remember. Okay, here I will give you the product, then you can at least try. After reaction of XeF4 plus O2F2, what we get is XeF6 we will get. XeF6 we will get and oxygen will be liberated. Understood? So you can find out the number of lone pair on central atom of xenon in the product. Answer will be 1. Okay. Next, which one of the following compounds can contain bond between same type of atoms? That means sulfur to sulfur, boron to boron, nitrogen to nitrogen, like that you have to identify. Okay. There can be any number of bonds, but there should be bond between them. Okay, these are the structures which have 4. 1, 2, 3, 4. Here it is sulfur to sulfur bond is there, nitrogen to nitrogen bond is there, sulfur to sulfur bond is there, nitrogen to nitrogen bond is there. Okay, answer is 4. Number of NMnCl bonds. Okay, NMn is cis to NNCl. Okay, you can try. Otherwise, actually here it is the question from the coordination number. So you can try. Otherwise, I will tell you. Okay. Number of NMnCl bonds. Okay, here what they wanted to ask, I will tell you. See, Mn, okay, Cl and Cl. This is a square bipyramidal shape, okay. So here on the cis it is said, En means amine, okay, ethylene diamine, understood? So I am writing only nitrogen, rest all also will be there. So number of NMnCl. So like this you can count 1, 2, like this you have to count 3, Okay, 4, 5 and 6. So total answer will be 6. What is the answer? Answer is 6. Okay, thank you very much for watching, and don't forget to watch the one shot lecture right from the beginning to last. You can make it into the 5 parts. Okay, as the lecture is very lengthy, you may feel boring after some time. So to avoid that boring and losing the marks, you can make that 4.5 hours. Okay, you can make that 4.5 hours video lecture into the 5 parts, like 45 minutes, but it is the only the shortest possible to get the all information. Okay, see you, bye bye, and don't forget to like.